Have you ever wondered the differences between Jenkins and Tekton? Hi, I'm Christine, and today I'm going to talk to y'all about the differences between the two. Two CI/CD tools that have the same goal, just achieve them in different ways. Let's start with the basics. To understand Jenkins and Tekton, we first need to understand continuous integration and continuous delivery, or CI/CD for short. CI/CD is the process of automating software development through testing, building, and deploying applications. Jenkins and Tekton are two CI/CD tools designed to create what is called CI/CD pipelines. To learn more about continuous integration and delivery, check out the videos linked below in our description. But for today, I'm going to talk to you guys just about the similarities and the differences between the two. Let's start with Tekton. To understand Tekton, we first need to understand Kubernetes. Kubernetes is a container orchestration platform designed for automating application deployment, management, and scaling. Tekton runs on Kubernetes, allowing you to work with your CI/CD processes on the same cluster as your applications. This allows you to easily scale your workloads simply by adding nodes to your cluster. Tekton comes with a set of Kubernetes custom resources, giving you the building blocks to easily configure and manage your pipelines. You can automate Tekton either through the command line or through the Tekton UI in the browser. All right, now let's get into the architecture. So I'm going to start by giving a simple example to explain CI/CD pipelines better. Let's say you have an application that you want to deploy into production, and you want to automate this process by using Tekton. To keep it even simpler, you're going to run the following procedures on it. You're going to want to test your application, build it, and then deploy it. Each one of these operations becomes a step, which is the smallest building block of Tekton. Steps are where you can specify your commands, your arguments, your images to execute your processes. Once you've created your steps, you can organize them into what is called tasks. And a single task, you can have one step or multiple steps, depending on the order and sequence you put them in your files. So a task runs on basically a pod. And a pod is a single instance of a running process on your Kubernetes cluster. But we're not going to get into pods or clusters today. If you want to take a deeper dive, again, check out the videos linked below in our description. So the great thing about tasks is that once defined, you can reuse them in any pipeline you want. So say I have another pipeline that I'm working on that's dedicated solely to testing applications. And I want to use this test task because it has exactly what I'm trying to do. All I would have to do is reference the task name in my other pipeline. No need to rewrite anything or duplicate it. All right, so that brings me to the next topic, which is pipelines. And pipelines are a way of further organizing your tasks by controlling the execution of them. Pipelines allow you to organize tasks concurrently or sequentially, depending on the order they're placed. And pipelines and tasks are Tekton custom resources that allow you to control what gets inputted and what gets outputted from the tasks. For example, an input would be the source code of your application that you're running through the pipeline. And an example of an output would be the image produced from your build task. Okay? So inputs and outputs, these are called pipeline resources. And you can define them in your tasks or your pipelines, or you can put them in their own file, depending how organized you want to get. Okay, so pipelines organize the execution of tasks, tasks organize the execution of steps, and steps execute what you're trying to do. How can we automate this process even further? What fires off our pipeline? So a concept called a pipeline run triggers our pipeline, and you can declare that in the trigger template. And Tekton triggers allow you to detect and extract information from events from various sources that allow you to execute your tasks and pipelines. So what exactly does that mean? An example of an event would be, let's say we want to fire off this pipeline every time one of our developers commits changes to the code. There's a concept called the EventListener, which listens to specific events. In this case, it will be listening to our developer committing code. Once that happens, it will pick it up and it'll fire off our pipeline. All right. So as you can see, Tekton, its process is very structured. To put it even more visually, each one of these concepts is just a file. The event listener, the trigger template, the pipeline, and each individual task is its own file, a YAML file to be exact. And that's one of the biggest features of Tekton, is that it's object-oriented. It's modular. It makes it very easy to reuse and customize and organize, and it's super flexible. Okay? So I'm going to touch on one more thing before we get into Jenkins, and that is storage. How or where does Tekton store its CI/CD data? The answer to that is Workspaces. All right, so Workspaces, or let me back up. When we think of storage for Tekton, think of basically a very large file system, okay? And Workspaces allow tasks to declare part of that file system to use for storage. What are we storing? The inputs and the outputs throughout this whole process. To take it a step further, there's a concept called a persistent volume claim, or PVC, which lets you specifically define the location of that storage volume. And it lets tasks share them amongst the process. And you can typically define these in the trigger template. One more thing that you can also define in our trigger template is service accounts. And service accounts basically handle secrets or authentication with Tekton. So you've got passwords, you've got tokens, you've got SSH keys, and you want to make sure everything is secure before you run your steps. Tekton runs this credential initialization on each pod before it executes steps, keeping your whole process secure, which is very important. All right, so let's get into Jenkins now that we've got a good understanding of Tekton. The biggest difference between the two is that while Tekton runs on Kubernetes, Jenkins runs on its own servers, or VMs, virtual machines. So a part of Tekton running on Kubernetes means that it's made up of many different languages like Node, Python, Ruby, Java. Jenkins, however, is based solely on Java. You might be wondering, how can Jenkins even stand up to Tekton if it only supports features written in Java? The answer to that is plugins. Jenkins plugins extend the capability of projects written in languages other than Java. So say, for example, you want to use a version control system like GitHub. You would need to install the GitHub plugin on your Jenkins machine to work with it. Super easy to install. There's over 1,000 different Jenkins plugins, and you manage them and install them through what's called the Jenkins UI. Similar to Tekton, you can work with Jenkins through the UI or the command line, but mostly people use the UI. And on the UI is where you can manage your pipelines. Okay? So in that sense, it's very similar. But when it comes to the file structure, that's where they differ. Jenkins stores its configurations in what's called a Jenkins file, which is one large file, like so. So going off the same example I used over here, you've got an application that you want to deploy to production and you want to automate this process, but this time using Jenkins. What you would do is you'd create a Jenkins file and you'd come in here and I'm going to use this. You'd come in here and you'd declare your Jenkins pipeline. You want to test, make sure there's no errors or bugs. You'll want to build it, and then you'll deploy it. And over here in Jenkins, they're referred to as stages, whereas Tekton, they're tasks. And within each of these stages, you'll have your steps, which is really the meat of what you're trying to do. It's where you have your scripts, your commands, your arguments, parameters. It's held in the steps. So as you can see, looking at the structure, it's already a little different. We've got a 3-part pipeline defined in one file, while over here we've got about 6 different files. So the Jenkins file lets you configure not only your pipelines, but you can do a lot more other things in here. For example, you can define functions like exporting archives or security functions that you want to run throughout your process. There is methods. For example, for authentication, there's a method called credentials, where you would define in here. And this deals with secrets and authentication. For firing off the pipeline, similar to the EventListener in Tekton, there's a concept in here called Webhooks, which, very similar, you would program it to listen to specific events. For example, your developer committing code changes or creating a pull request. You'd define it like so, and once that event happens, your webhook would fire off your pipeline. Okay, so storage. Conceptually, Jenkins and Tekton are pretty similar. Jenkins uses file systems just like Tekton. But when we think of storage with Jenkins, they organize their directories a little different. So Jenkins has this home directory called the Jenkins home. And inside this directory, you'd have a lot of other directories where you'd store your build logs, your configurations, your artifacts. For example, there's a plugin directory where you'd store your plugins, or you'd have a secrets directory where you'd store your secrets. But most importantly, I think the workspace directory is where you'd work with the most. And the workspace directory is your working directory wherever you run your pipelines. So every time you run a pipeline, its build generates some artifacts, which, think of it as files or images. It's kind of like outputs in Tekton. And you have these artifacts, and you want to use them in your next run or your next stage. And so you got to save them in your workspace so that they're not wiped out completely with the next build. You would do so by storing it in your workspace or archiving it elsewhere. Okay. So now that we've got a good understanding of the two, you can kind of see how conceptually Jenkins and Tekton are very similar. At the end of the day, they're just trying to automate the software development lifecycle. They're just trying to make a developer's life easier by getting rid of all of the manual steps as much as possible. Let's review a little bit about what I just went through, the biggest differences. So the biggest difference is, one, Tekton runs on Kubernetes, allowing you to easily scale your workloads to enterprise levels, while Jenkins runs on its own servers or VMs. It's Java-based, and it uses plugins to extend its capability. Number two, Tekton, it organizes each component of its pipeline into its own file, making it very organized and easy to pinpoint. While Jenkins uses one large Jenkins file to store its configurations and configure its pipeline. And then lastly, going off of this file structure, the fact that Tekton divides or organizes each file into its own entity, it allows it to be fully portable. So once defined, anybody in your organization can come in and reference your pipeline resource and use it in their own pipeline, making it very efficient for them and not having them reinvent the wheel every time. Whereas Jenkins, it's a little less organized and it's not as easy to pinpoint exactly what you're trying to reuse. So I hope that helped. Thank you so much. If you have any questions, please drop us a line below. If you want to see more videos like this in the future, please like and subscribe. And don't forget, you can grow your skills and earn a badge with IBM Cloud Labs, which are free, browser-based, interactive Kubernetes labs.